Hey there guys, so this is lesson 2.5, Bool in the house. Bool is, well, what we're going to do is you're going to learn how to define and identify Boolean expressions and operators and evaluate those Boolean expressions. You will use the Boolean operators in the lab that you're going to do. And those Boolean operators are and, or, and not. Think about the kind of blocks that can go into your conditional statements. Specifically, what do the blocks that go in the holes of the if blocks have in common? If you remember, or if you have Snap open right now, or I'm not sure if you do, but they have pointy ends, and because that's part of a condition that has to be met. So when we talk about Boolean expressions, Boolean expressions and Boolean operators are used in Java. They're used in all kinds of different programming languages. And basically, all a Boolean expression does is determine whether a statement is true or false. So in Snap, all Boolean expressions are pointy six-sided blocks. You have the AND block, and you have an OR block and a NOT. Now, if you look at the AND block, in order for this block to be true, both sides of the statement have to be true. So you would put two different equations or conditions or whatever, one on this side and one on the right side, and for it to be true, both statements have to be true. For the next statement, though, if you're using OR, in order for this block to be true, only one of the statements on either side of the block can be true. So you could say on the left side, if 1 plus 1 equals 2, or if 1 plus 1 equals 3, then it's true. Well, obviously 1 plus 1 is 2, so we're going to have a true statement there. This last one will be used occasionally. Sometimes you have to think about it a little bit different, but it's a block that reverses the statement. So if you have something that's true and you put a not, put it into this spot here, it will negate it. It will say it's not that. Boolean operators are themselves Boolean expressions, and they can also be nested. So you could be comparing three different statements by putting two in the AND block on the left and one on the right, but it's all, they can be nested. By the way, over here you see this is, Booleans are named after an English mathematician called George Boole. This next slide, if it switches over for me, there we go. This next slide has three different blocks, and I want you to take a look at each one of them. This top one says 5 is less than 7 and 4 is greater than 2. So what we're trying to figure out, is that particular statement going to be return a true value or a false? Well, 5 is less than 7 and 4 is greater than true, so this would return a true because both statements are true and it's an AND block. This next one has set x equal to 7. And in this, it's got the x variable is either less than 5 or the x variable is greater than 10. Well, 7 is not less than 5. And 7 is not greater than 10. So this would return a false statement because only one of them would have had to be true. If this would have said if 7 is greater than 5, it would have returned a true, but it doesn't, so it doesn't work. This next one here is kind of interesting. These are nested Boolean operators. And so right now we have an OR. So either this could be true or this whole statement could be true. In this case, they've said x equal to 4 and y equals to negative 3. So right now we know that this left side, there's no way that's going to be true. But we've got to check it in this side of the block. And in this side of the block, both of these would have to be true in order for this OR statement to have to be true. Because it has to either meet this condition or it has to meet this. And we already know the left side is not meeting the condition with the variables the way they've been assigned. But on this case, we have x is 4. Well, 4 is definitely greater than 0. And we have y is negative 3, which is definitely less than 0. So this whole statement is true because they are both true, which makes this entire statement true because one of the sides of the OR statement are true. Hopefully that makes sense. It can be a little bit tricky when you're looking at these operators. So that gives you the general gist of the idea. And you can even use join statements and put these things together and compare them in a sentence. There's just all different ways you can use Boolean expressions, and you will get a chance to do that pretty soon. So let's look at the next slide, which is going to be about what your lab is about. Okay. So we will be going to Snap in just a moment so that you can see what this first part of the lab. Now this whole lab is about different kinds of triangles, but I want to just talk right now about the first part of the lab. In order for a triangle to actually be possible, if you have 3 sides of a triangle, so I'm going to take you to another screen here in a moment, but I want you to pay attention here. In a triangle, if we have sides A, B, and C, any 2 sides that are added together have to be greater than the third side in order for it to be a triangle. So A plus B would have to be greater than C, A plus C would have to be greater than B, and B plus C would have to be greater than A. So this is just the first part of the lab. So I'm going to take you to our little paint program, and I'm going to show you how that works, and we can talk about it a little bit more. Here we go. So here's a triangle. Really exciting, isn't it? Okay. So if I decide I want to label a triangle, let's see here, 1, 1, and 2. Sorry, this is what happens when you have a mouse and a laptop, and I don't have a touchscreen. So anyway, we all know that 1 plus 2, which is 3, is greater than 1. And 1 plus 2 is also greater than 1. But here's the deal. This is not a possible triangle because 1 plus 1 equals 2. It's not greater than 2. So there's no triangle here. Kind of messy there. Sorry about that. So let's do something else now. So let's get rid of all of this. And I'm going to pick a right triangle. Okay. So many of you know what a Pythagorean triple is if you have taken geometry. If you have not, a Pythagorean triple just means we have 3 side lengths that are whole numbers that create a right triangle. So I know that 3, 4, 5 is one of the most famous, so I'm going to write 3, 4, and of course the hypotenuse has to be the biggest, 5. Well, 3 plus 4 is 7. That is greater than 5. 5 plus 3 is 8. That is greater than 4. 4 plus 5 is 9, which is greater than 3. And we already know that this is a right triangle because this is one of the most famous triangle lengths that can be. But that's what you're going to be doing in the first part of your lab, is you're going to be determining if the triangles, or if the lengths that a user gives you are a possible triangle. So let's go back. So this is going to require you to do some Boolean testing and to do some nested things, like if A plus B is greater than C, and A plus C is greater than B, and B plus C is greater than A, then you have a triangle. If any of those are not true, you will not have a triangle. So you're going to have to figure out how to do these true-false statements. So what I'm going to do right now is take you into Snap and show you how my solution runs for this first part of this lab. So here we go. Okay, so in Snap, you'll see that part of this is to, if it is a triangle, then you're going to return the perimeter back to the screen. So I'm going to go ahead and start this, and I have initially started it so that all of my variables will be set equal to 0. And then if you remember, you're going to have to ask a user for how to, or what lengths they want to use. And remember, that means you're going to have to create variables. You're not going to use the answer block, because if you use the answer block every time, it's going to ruin what you're actually trying to program. So you're going to set variables first for A, B, and C. As you can tell here, I've already got variables for A, B, and C created. And then I also have a variable for perimeter. So let's run the program and see how this part of the program runs. please give me the length for side A. So I'm actually going to give the first example I gave to you of one that doesn't work. So I'm going to choose side length 1. Then it asks for side B. I'm going to pick 1 again. Then it asks for side C, and I'm going to pick 2. I am sorry, you have given lengths that could not form a triangle. So I'm going to try it again. And again, it's going to get rid of all of these because I've got it set to set everything to 0 at the beginning. So everything's 0. Please give me, and this one I'm going to do the famous one, the Pythagorean triple, 3, 4, 5. So please give me the length for side A. Well, I'm going to give it 3. Then I'm going to give it 4. And side C will be 5. Now I should get a perimeter of 12 and a message that says my triangle is good. The perimeter for your triangle is 12 inches. So I have completed part 1. This is all part 1 is. Okay, so we have already discussed what happens in part 1. In part 2, you're going to do what kind of triangle. And if you look at number 1, it says add code to your program to determine and say whether or not the triangle described is a right triangle. If the triangle has side lengths A, B, and C, then the triangle is a right triangle if the following is true. So you're going to have to ask that question. If A squared plus B squared equals C squared, then you have a right triangle. After you do that, then you're also going to be asked to determine what kind of triangle the user is using. So a triangle can be a right triangle, but can also be an isosceles triangle, meaning all the side lengths or 2 side lengths are the same. Or it could be a scaling triangle where all 3 side lengths are different. So our 3, 4, 5 triangle, yes, that's a right triangle, but it's also a scaling triangle because all 3 are different lengths. And that's called a scaling right triangle. So, but you also have to determine if they're equilateral triangles. So that's what you're going to be doing for this particular lab. We'll go to Snap again here in a moment, and I'll show you how my solution runs. So I keep saying so a lot, but that's just the way I am, and I am sorry about that. So lab 2.5 criteria. This is all what you would be graded on, and obviously because of this coronication, I'm not able to grade it. But I will be making comments on things. So I want you to put 2 minimum comments in it. I want you to have no fruity pebbles, which means no loose code. And I want you to start with a green flag. And I want you to successfully identify an equilateral, an isosceles, and a scaling and determine if the right triangle works and whether or not a perimeter, an actual triangle given the lengths is actually a triangle based on what we did from part 1. So let's go to Snap. Okay, we're back in the Snap screen where it's going to run, and I'm going to put in a 3, 4, 5 triangle so you can see whether or not it's a Pythagorean triple. So here we go. So please give me the length for A. 3, 4, 5. So we already know it's a triangle. There's the perimeter. You have a right triangle because it does the Pythagorean theorem. And you've chosen side lengths that create a scalene triangle. So we are now going to do one more. We're going to do an equilateral triangle. So let's just pick the side length of 6. And 6 again. And 6 again. The perimeter is 18. You have chosen side lengths that create an equilateral triangle. So let's pick a scalene one that's not a right triangle. Here we go. This should be a scalene non-right triangle. I'm going to pick 2 for side A. I'm going to pick 6 for side B. And 7 for side C. Perimeter is 15 inches. And you've chosen side lengths that create a scalene triangle. So that's what you're doing. That's what the lab is about. So hopefully you understand that and you can get started on the lab. I have uploaded this document into Schoology, as well as, let me find that other image. Hang on just a second. Okay, I found it. And I've also uploaded this so you know the properties of the different triangles that you can work with. So you should already have this cheat sheet from previous activities, as it says here, but in case you don't, you will have it here and you can download it and print it at home. Okay, now you should have everything that you need for this lab. Remember, you can always email me or send me messages on Remind if you have questions. In addition, we can set up office hours if you would like with Aaron and Jessica. But the last time we set up office hours, nobody showed up. So we're not going to do that unless there is a need to do it from some of you students. So please let me know. I'm going to sign off now, and I hope you're all staying safe and that your families and you are getting some good quality time together and that you enjoy your spring break, even though most of us aren't going anywhere. I miss you guys, and I just hope you're doing well. Take care. Bye.